Hey everybody, so I just want to walk you through a new bootstrapping command line tool that we've been building for .NET apps. It's called Shock, and I suppose it's fairly similar to some other tooling you'll have seen, task runners, maybe like Rake. So first, who am I? Well, my name's David, and I'm a freelance software consultant. I've worked with and at some really fun organizations that build lots and lots of software. And tool building is something that I care relatively deeply about. I think as programmers we should always be trying to find the best way to solve our problems, and if that means actually rolling up our sleeves and doing it ourselves, then we probably should. So, what's Shock? Shock exists to provide an answer to a very, very simple question, and that question is, how can I run this piece of code before my application starts? Now, this could be any kind of code. Let's elaborate on it a little bit. It exists to let you write admin scheduled tasks. It exists to let you write bootstrapping tasks in C# in your application. You know, the difference between this and maybe PowerShell scripts or batch files is that you have access to all of the language features, libraries, and methods, and you can basically build whatever you want. And most importantly, you can run all this stuff from the command line. So, you know, I hear your brain whirring now. So you're thinking, oh, is this a task runner like Grunt or Gulp or any of the other stuff from the Node ecosystem? Well, actually, no, not really. So Shock isn't about your development workflow, and I think that's a really important distinction. While you could use it for development tooling, really this is a small utility that you can use to build deployment pipelines, to build automated tasks, to do database migrations, admin, random tasks, maintenance jobs, automation. That's what we're really thinking about when we think about writing tasks for Shock. Not CSS bundling minification, not various other kind of build events. And the idea is that all those random tasks often get distributed around your code base. They end up in random places in source control. And you know, I thoroughly believe that the best place for those pieces of code is right in your system, in your application, with all the rest of the code that the tasks describe. So what are the features? So running the Shock command line tools will load any .NET applications that it can see. So what we're talking about here is we scan directories, we look for DLLs passed in on the command line. We look for things that we recognize as tasks using some detection heuristics, and then those tasks are surfaced in a way that you can invoke them off the command line. So it'll do some pattern matching, and you can run any methods that you mark as tasks just by invoking them by name. You can pass parameters, and you can return codes and output codes. You can also customize the discovery and execution mechanisms of Shock via extensibility hooks. So we're going to do a bit of a deep dive into that later. Shock is kind of sort of inspired by a tool called Bounce, which a couple of my clients have been using. It has very, very similar goals, but we keep on running into limitations around the way that you have to compile down your C# code separately and commit in the compiled binaries into your source control repository. We didn't really want that constraint with Shock, so we would prefer the tasks to live actually inside the application rather than some satellite assemblies. Shock is less opinionated than Bounce. Bounce is more a .NET-y version of Rake, so it's meant to automate IIS. Shock is just a task runner. There's really very little about IIS or deployment or anything in the core code base itself. But we did have a couple of design goals. So from the offset, we wanted to make sure that Shock works without any direct dependencies from your application. There should be nothing about a task that makes it a Shock task. It should just be a chunk of code that you can use for automation. We should be able to point Shock at some code, a directory, a DLL, an executable, and it'll just kind of do the obvious thing, work things out by default. The tasks that you expect to run or be available should be, as if by magic. So we're talking about discovery heuristics, like if I only have a single task in an application, well, actually, if I just type Shock, let's just run it. That's what I wanted to do anyway. And it should be safe by default. So we're talking about useful errors, no random unhandled exceptions, return codes that come back out of the box that you can bundle into build scripts and pipelines. It should be useful. And to do that, we kind of came up with a set of deliberate constraints. So Shock should be standalone. It should have 0 dependencies, no tooling, no configuration, just an executable. It should be packaged in that way, so we should be able to get it from NuGet or Chocolatey. It should be able to run any task it finds, regardless of framework versions. And the consuming applications should be able to override all of the behavior at runtime. Basically, it's important that Shock has no special configuration. It was built to auto-discover and auto-load relevant web and app configuration files. So what we mean is that when you're in the context of writing a task inside of your application, if you think you have a connection string there, or if you think you have an app setting there, when you invoke that task through Shock, it absolutely should be there anyway. And really, everything should just work is the principle that we hold above all else. It's really important to stress just how core this rule is. Too many tools require too much configuration and environmental management and hassle. And remembering arcane command line arguments, we don't want any of that. We want something that's really, really simple, to the extent that the default use case should be little more than writing a script that changes directory to where your binaries are and just invoking Shock. So it was designed from the start to just do the right thing by default, without anyone having to remember anything about it, really. Right? I mean, isn't that a miracle? Something that just works? Okay, so it doesn't look like much, and that's kind of the good thing about it. It really doesn't look like much. So Shock is a command line tool. If you invoke it and it can't find anything, you get something that looks a little bit like that. You get a bit of a prompt that gives you some hints as to what it'll do if you call it in different configurations. But really, there's nothing more to it. We have a couple of conventions that it follows, though, and they're probably worth explaining before we dig in. So something counts as a task. We discover a task if if a method is declared in a class where the name of the class contains the word task, if they have an attribute applied to them with the name task attribute. So in a bit of a funny wrinkle, we don't require you to take a dependency on Shock, so you have to implement your own empty task attribute. But if you do that, we'll find it and we'll count anything that has it applied as a method. Shock subsequently excludes anything from its discovery if the class is found in the system, accessibility, or Microsoft namespaces, or anything inside Shock itself. So we don't want to be introspecting ourselves. So we run the discovery convention, we get a load of candidate tasks, and then we run the selection conventions. So Shock will execute a task if the declaring class is called default task and the name of the method is run. So if you find a method called run in a default task, it'll just do it. The method name, full name, or the class name and method name are found passed as a command line argument. So if you've got a whole load of candidate tasks and we put the name of the tasks on the command line, it'll run the tasks. At that point, if only a single task is detected and no command line arguments are provided, as a lazy default, we just run that anyway. So I'm going to do a couple of little demos here. Let's switch over to the command line and we'll see what we can do. So this is Shock. Well, this is the debug directory of the executable itself, and you'll see that if I just type Shock here, you get the usages. So equally, if I type Shock and help, we get that same thing. And you see a couple of options here. So by default, it's telling you if you just type Shock, it's going to scan the directory that it's currently in for any assemblies and execute some default tasks. So what I've got here is I've got a directory that I prepared earlier, which is just that. So we've got a sample application here. And you can see here, there's nothing more than a default task, which will write out to the console. So what we're going to do here is we're going to switch into that directory, and we're going to call Shock. So let's navigate up. change to change to our samples, that directory. So cd samples. See, there's one application there. And if we change the bin directory, you'll notice that we've got our compiled DLLs here. So if I now, let's hopefully get this right, shock bin, let's guess here, shock solution, source of course, shock bin debug, shock, it's going to run in that directory. And you'll notice you get a little bit of debug information, so it'll tell you that we've found a web config file, because we did in that directory. And then we discovered shock sample app.dll, and we ran it. So it even prints out the full namespace, so shock sample app default task run, which completely matches with that there. And you'll notice that that's the words default task in our task here. So if I just change this to something else here, and do a little rebuild, and I run that again, there we go, default task 1. So what's actually happening there is the shock binary is running, loading all the DLLs that it can find, detecting a configuration file, and then finding the default task called run and executing it. So what else can we do? Well, what happens if we do that in a directory with no.NET binaries? So if I jump back over to my command line window and just go up a level, there's no binaries in here, and I run shock, you get the usages. And a web config, but it didn't find anything else. So let's drop back into the bin folder. Yeah, and here we're loading our task again. If I run it in a directory of multiple tasks, so I'm just going to drop back into my code file here, and I'm going to add another task to this. Let's not call it default task. Let's call it task. So I'm going to go task called run. I'll go to task called run 2. If I build that now, it doesn't match the default. So if I run shock, all of a sudden it's going to output the tasks that are available for me to run, because it doesn't know what I want to do. So at that point, if I do shock run, the first one, if I do shock run 2, it'll run the second one. So you see how you don't really have to remember any specific syntax, and it kind of works all these bits out. We can also pass parameters to tasks. So if I add a string parameter to run 2 here, hello, default task plus hello. So we add a parameter in there and build that up. Now if I run the second task from my command window, I can say hello equals ABC. And you'll find that now it says default task.abc because of my string concatenation in the task itself over here. So you see how we don't really have to pay much attention to argument position or where we're putting things. Shock kind of just works it all out on the way. And equally, if you want to see what Shock's doing, or if it's struggling to load something, you can run it in verbose mode. If I pop on there, you'll see how it tries to load. Well, you'll see that it's loading the DLLs that are available in the directory. It'll tell you what configuration file it loaded, and then you'll get the debug output from the tasks themselves. So that's the simplest possible example of using Shock. So generally, the way that we've been using it in our first couple of projects is we've been adding it as a NuGet package resource. We've been setting it to output itself into the bin directory of our main web apps. And as part of the build chains, we've been having our Octopus deployment pipeline invoke Shock on the command line, and everything else just shells back to our application. So it's pretty productive. So let's talk about how it works, because it's a little bit interesting, at least to me. So The code topology of Shock itself is very, very simple. It's meant to look like what it is. It's an application structured by feature with clear namespaces and obvious concerns. So if someone asks me the question, what does Shock do? I could pretty much read through the namespaces. It does type activation, argument parsing, it loads conventions, it does environmental discovery, it does task execution, it has some logging output, and it does discovery. That is what Shock does. That's all it does. That's all of its features. It looks like a bootstrapper. All the namespaces are named after those features, with the little concessions to app domain, munging, hidden away in the closed up folder there. It's interesting because some of the constraints that we set out with, we've made a couple of tactical choices. So argument parsing is probably much more appropriate to be solved with a third-party library. In this case, we've rolled our own. This probably won't be the design decision that lasts forever, but we've rolled our own on the basis that it helps us avoid doing weird IL merging to meet a single to meet our design goal of a single deployment executable. We could probably do IL merging later, but because Shock does a lot of manipulation of the contents of the app domain, we wanted to minimize the possible points of failure for that at this point. The file topology is incredibly simple. The truth is that Shock is not a large program. It's actually as small as we could possibly make it, with just the occasional concession and wrapper classes, where existing prior art would have probably been better to minimize dependencies. Basically, Shock looks like the kind of application that it is, and I think that's a really useful trait. We've got some clean-looking command line apps. So if you've ever thrown together a command line app, one of the main problems that you'll see is that your main entry point always ends up with a lot of horrible, ugly control flow all over the place. So with Shock, we took this as a bit of an exercise to see what it could possibly be, what we could potentially make control flow of a relatively abstract program look like. And the truth is, we were test driving out the core functionality of the app, so all of the main bits and the static context of our main method were pretty light. Really, this is just bootstrapping code for the bootstrapper. Wonderfully meta. It's practically a glorified factory class that wires up the Shock runtime environment, if that could possibly be seen as a thing. We made some particular choices here. We went with using a using block for syntactic sugar. It's actually, there's nothing that we're disposing of here. I just wanted to denote some kind of scope. So what you're seeing here is the execution environment gets the raw command line arguments. It does some stuff. It does some magic that we'll take a look at in a minute. And then once it's understood that magic, it uses the default command argument parser to parse those arguments, and then it invokes the punnily named defibrillator class, which shocks your application into life. You'll notice that we've got exit codes coming out. So one of the conventions we've implemented in Shock is that if you have a single task and it returns an integer, we'll use that as the command line exit code. Otherwise, we have our own exit codes that we bake in if you return void or more than one task executes. We've also got a little bit of a quirk there where if there's an interactive command line flag passed, we will pause execution for debugging reasons. So you'll notice that when we called Shock on the command line before, it offered a hint that we could use the interactive flag. What that will do is it'll trip that read key there. The simplicity of the code actually hides a little bit of the cleverness. It in itself is the bootstrapping code that loads the environment and attempts to auto-detect conventions before we start looking for things to execute. So this is really important because it gives us a way to hook execution and let the final consuming application where the task lives override some of these discovery heuristics. So what we're doing here is we're loading anything we can find from the command line. So we're taking the current working directory and any DLLs specified, and we're loading them all up into Shock's application domain. We're then taking that application domain and we're trying to detect any conventions. So we've got a default set of conventions for doing things like type activation, overrides, things like that. We then pass our active conventions to our discoverer, which will modify them if anything is found in the client application that requires that. We then grab all the types in the loaded application domain and we pass it to the defibrillator along with the currently active task discoverer, task selector, and task runner, as well as our output channel. So basically all of those responsibilities are delegated up to the environment with the active conventions containing a set of safe defaults. You can kind of see how this is a glorified factory method, really, with some fairly trivial poor man's DI. The notion is that any matching conventions are applied to the instance of active conventions that gets passed into the punnily named defibrillator class, and then that class orchestrates doing all the real work. So Shock's bootstrapper provides default conventions for task discovery, selection, and execution. Before it attempts to find or execute anything, it tries to locate and run anything that wants to modify its own behavior. This is very similar to how Owen and the app func works. It doesn't require the target app to know about Shock, just provide a few functions that match some default conventions. By scanning for conventions before we do anything else, we can allow our user applications to modify Shock's behavior trivially. So in the code base, the default conventions are very, very simple, and they're represented inside the Shock-created single instance of the active conventions type. You can manipulate any of these conventions in a couple of programmatic ways, both with and without taking a direct dependency on Shock itself. So you notice that we use activator create instance by default for our dependency resolver. If you, for instance, had a container that you wanted to wire up, you could do that there. You probably need to put a shim around it, but it's a trivial implementation. We have our own default argument parser. Maybe you'd want to use something better. We've got our own default task executor. So this is single thread. It doesn't support parallelism, but there's scope for movement there. Likewise, we've got a discoverer and a selector, which you could override to change the rules that Shock uses to find and discover components. And we default to a console output. So if you wanted to override the conventions and take a dependency on Shock, it's actually really simple. You just need to add a class that looks like this. Doesn't matter what the class is called, but you need a class in your application that takes the type active conventions as its single constructor parameter. If you do that, Shock is going to scan and discover it, and it's going to invoke it. And you can do anything you like with those conventions during constructor invocation. So this is a real simple, very, very easy plugin pattern to implement. I mean, you can rip it off and steal it in your own code base. Very, very easy to scan an application domain for any type with a constructor that matches that pattern. The slightly more tricky approach doesn't involve taking a dependency on Shock. So if you modify the conventions without a direct dependency, you have to provide a class with the method names and signatures that match our default discovery and selection implementations criteria. What that means, practically, is you need to provide a method called configure task discovery and configure task selection in a type. Now they can be in separate types or they can be in the same type, but you have to make sure that the default parameters exactly match these method signatures here. So you need to make a method called configure task discovery, which takes a list of functions with the parameter being a method info, returning a bool, and a list of functions that takes a type, returning a bool. So those represent our default implementation's match and exclusion rules. Once you get given those two lists, you can add and remove or clear the functions available, and our default implementation will use your rules that you put in there. So this example here just clears the match and exclusion rules. So obviously no tasks will ever be found if this class exists in your code base. Similarly, you can implement a configure task selection method, which rather obnoxiously takes a list of functions that takes a list of method infos, which represent all the candidate tasks that have been discovered, a dictionary of configuration values, which represents the raw configuration from the command line, and returns an enumerable of method infos that have been selected, which is meant to be a subset of the things passed in. Again, modifying this list is not that difficult, but the syntax is a bit ugly. It's syntactically complex. It allows you to adjust the default selection criteria. It's a bit of magic, we'll go with that. These method signatures are very, very hard to remember, and you'll probably be copy and pasting them every time. But if you desperately don't want a dependency on Shock, we can do it this way. Configuration discovery. So this is a little bit of, I suppose, curiosity. So to follow up on the promise of having everything just work, we wanted to make sure that all of the configuration settings that an end user dev might attempt to load at runtime were just there. So when Shock is scanning for DLLs to load into its application domain, it looks for matching webconfig, appconfig, and assemblyname.dll.config files for each of the assemblies that it discovers and loads. See, the premise is that the first one that exists is normally the right one, with web and app configs taking precedence over specific DLL configuration files. So there's just a little bit of syntax there that says first look for web config in the parent directory, then web config in my directory, then app config, and then for each of my loaded assemblies, look for a matching DLL config, and if it exists, take the first one and try and set it as the configuration. So the actual configuration loading is kind of interesting because mostly it uses a little known corner of the .NET app domain, which is the ability to set the relatively poorly documented app config file setting on the current app domain. So that's it. There's no real magic there, but when you set that, you can change the current contextual application configuration to whatever you like. Generally, you don't see people doing this very often, but we can get away with it, so we do. We can only get away with it because Shock itself requires no configuration. If Shock required its own application configuration file, this would all get very messy very, very quickly, and we'd have to start loading DLLs into a separate app domain and remoting across to it. So we've been able to leverage these little tricks to make quite a small code base that can do a lot of useful things. So it's all very, very meta. Shock literally does nothing that you haven't asked it to do in a task, but you can see how you can take this small command line tool and plumb it into your build pipelines and processes. It's on NuGet right now. It works. It's in production for a couple of things. Hopefully this is something that might help you guys with some of the work you're doing out there. By all means, we'll take feedback and pull requests. Thanks a lot, guys.